Good evening, everyone, and welcome to our webinar on microgrids. I'd like to begin by acknowledging the traditional owners of the land on which we meet today. I would also like to pay my respects to elders past and present. My name is Sowmya. I'm the project manager for the Grampians Community Power Hub. The Community Power Hub has been established to support locally based community groups to develop and implement community-owned renewable energy projects. Our activities are mainly supported by Breeze and Happen Energy with the grant funding we received from Sustainability Victoria. We have three very knowledgeable speakers here with us tonight to talk to us about microgrids. But before I start with introductions, I'd like to just mention that everyone please type your questions into the Q&A tab, and we will go through them all together at the very end of all the presentations. Now, I would like to introduce you all to Matthew Charles Jones, founder and president of Totally Renewable Yackandandah, which is a volunteer-run community organization. With Matthew's support and leadership, the organization has worked on several renewable energy projects. Let's hear Matthew talk more in detail to us about these projects, more specifically on microgrids. Matthew, over to you.
So Matt Charles Jones, Totally Renewable Yak. Our group's got a goal of being 100% renewable by the year 2022. The township of Yak already has 3 microgrids in various states of activity. And really, I guess one of the things we've observed about our microgrids is that they are really very much about a general goal of transitioning the town to Yak to 100%. And really that 100% is about how do we generate, store and share renewable electricity right around the town. And with a really critical goal of making the township islandable, and the definition of islandable being such that if the main supply from Wodonga, in our case, was to fail, the township can still have electricity. And there's a few features which are very commonly regarded as important features of a microgrid, and islandability is one of those. It's also, in the current context, common for a microgrid to include some form of renewable generation, and whether that's about hydro or micro hydro, renewable solar, or perhaps wind as well, and then other less common ways of generating renewably. The other important feature of a microgrid is the inclusion of some sort of smart energy controller, and there's a whole range of different ones available on the market. The one we've used commonly in Yackandandah is one called a Mondo Ubi. And the Mondo Ubi is really just a device that has the capability of controlling an inverter, a solar inverter, and a battery to be able to deliver some type of shared service. So the other thing that seems to be really important in the function of a microgrid is the ability for people to be able to operate interdependently. And so for a microgrid to function, you need normally a range of sites across a geographic area. And the geographic area in Yackandandah has commonly been about 14 homes, and in some instances amongst about 20 homes in total, or in another instance about 100 homes. And our goal in Yackandandah is to transition the whole town to a microgrid so that we can both be interdependent with power, and that if the main supply from the national energy market fails between Yackandandah and Wodonga, we can still continue to have a power supply. And it ties into some of the thing that's really apparent in Yackandandah, that we have a couple of really key motivations which initially launched us on the pathway with microgrids. One of those motivations was really, how do we develop an energy supply that is more resilient? And so by having a microgrid, it provides a scenario that either for a single property where somebody's got a solar system, for example, and a battery, they can continue to have a power supply, assuming there's charge in the battery. we're also really interested in what happens when people stop spending so much money on electricity and what effect that has for a whole town or a whole area. And really clearly, one of the things that has been important for Tribe and many community energy groups is the extent to which we can use microgrids as a really important mechanism to respond to climate change in its first instance around carbon emissions reduction, and then secondly from the point of view of when we experience extreme weather events, and we've seen lots of those in Australia in the last little while, there are pathways to be able to have a local power supply. And so in us developing our microgrids in Yackandandah, we really set up a 5-stage process to get from where we were in 2014 when we started to a position that we are a fully functioning microgrid at some point in the future. And stage 1 really was about business as usual. There was a casual take-up of solar and in some instances battery. And we felt that that was not an ideal outcome from the point of view of climate change, to understate the matter. So we launched a program in our effort to build a microgrid right across the town of solar bulk buys, including this smart energy controller, the Mondo Ubi. And the next phase of that process on our 5-stage pathway was then to work through with the addition of batteries, and we're just about to launch onto another battery offering associated with an ARENA funded program, which will be subsidising batteries. But again, really building towards that microgrid. We've got a bunch of people with really good quality solar, and now we're adding batteries to that. And in many instances, they've already got the smart energy controller, which will be the brains behind the microgrid. And happy to talk about that in questions. And so stage 4 was the adoption of some sort of mechanism to be able to trade electricity locally. And one of the other speakers, Nick, will be talking about Indigo Power. So I won't talk about it too much, but we saw that as an important mechanism for us building our microgrid. And then stage 5 is the inclusion to give a real backbone to the microgrid of scaled generation and storage. And in Yackandandah, we now have a community-owned battery. It's 274 kilowatt hours coupled with 65 kilowatts of solar. And that community battery really starts to provide the impetus to have real scale in local electricity, to be able to give that islandability capability the potential to run more than just an hour or a little while. And our goal in the next few years to really add scale to the solar and battery system. So that's probably getting close to the end of my time, and one of the things that we've really recognised is that the build-up for us to create microgrids in Yackandandah hasn't been suddenly we decide to create a microgrid. It's been thinking about what are the elements that we can develop over time that give us the collective capability of being able to run our town that's islandable, that is interdependent, and has the goal of being resilient, so that when the energy system fails, there's backup. But day to day, we're really keeping our carbon emissions to a minimum, and also building on local economy.
Thank you, Matt, for the great talk, and hopefully you will have some more to talk about during the question session. Now, I would like to introduce a second speaker for tonight, Dr. Scottt Dwyer. Scott is a research director from the University Technology of Sydney and has a lot of knowledge in the clean energy space. One of the projects he's working on is the My Town Microgrid project in Heyfield, which he will now speak to us about. Scott, over to you.
Thanks there. And I'm nervous now. I'm going to hit share and I'm hoping it works.
It's
Okay.
fine.
Phew. Okay, that's great. Thanks everyone. Thanks for having me here today. So I'm representing the University of Technology Sydney Institute for Sustainable Futures, and here to give you a rundown on my town microgrid, Heyfield, which is a innovative microgrid feasibility study for the town of Heyfield in Wellingtonshire. So, and I was just going to give you a little overview of the project and highlights from one of our most recent milestone reports to the Commonwealth, because it's a Commonwealth funded project, on the lessons learned for future projects. So I'll give you a little run through of those. You can just see through there at the bottom of the project of the slide, all the different partners there as well. So Watt Watchers, the lead, Heyfield Community Resource Centre, our community partner, funding from the Latrobe Valley Authority, the Public Interest Advocacy Centre, AusNet Services, Community Power Agency, and 3 universities, UTS, Federation Uni, and RMIT. Just give you a quick rundown overview about my town. So it's a 3-year microgrid feasibility project, so not implementation, just understanding, does a microgrid make sense for the town? We received around $2 million total in funding from the Commonwealth through their Remote Regional Community Reliability Fund, Microgrids. They've funded around 24 microgrid feasibilities around Australia. And we also received funding from the Latrobe Valley Authority as well through their Smart Specialisation Strategy Fund. We've got partners, as we said, quite diverse set of partners. And really what we're wanting to do is to develop this novel approach that will make it easier, faster, cheaper for other communities to understand whether a microgrid actually makes sense for them. You can just see here, the people are familiar with Heyfield, but you can see there on the left an aerial shot surrounded by lots of beautiful farmland, and not too far you've got the hills and some beautiful forests and wilderness. You've got below that you've got a large timber mill and manufacturing plant from Australian Sustainable Hardwoods. On the far right, top right, you've got the Watt Watchers devices. So these are energy monitoring devices that go on your board, which we use to understand the energy use of the town. And we've got Julie there in the middle image top, who's from the Resource Centre, is really a driving force behind a lot of the sustainability initiatives. Local MP, Darren Chester, and the manager of the IGA. And you see the Resource Centre down at the bottom as well. So, yeah, so that's the main premise of the project. We're about halfway through the project just now, so I'll take you through the timeline. We started in the middle of 2020. You can see here that little picture at the top left. That was our launch meeting. We had around 60 community members turn up for that. So it was a great turnout. I had no idea how many people would turn up, and this was really about framing telling everybody what the project was about. We've through that first year, we started installing the Watt Watchers devices in different homes and businesses. You see there our local friendly electrician installer, Brenton, and our community liaison officer, Emma, beside one of the first installs. In the last year, we went through a co-design process with the community reference group around how the different technical options were shaping up for how to get towards a microgrid. Of course, all online because we can do them in person, so that's obviously had its own challenges. We're currently working on the technical and economic assessment to see, okay, what's the mix of technologies, how big what's the size of battery you need, how much solar, how much you need to reduce energy demand, those sorts of questions. And then end of this year, we'll be looking to deliver a detailed feasibility and costing for Heyfield, for the microgrid or some other form of local energy solution, and what that might look like. And then the back end of the project was really about developing the tools and guides for other communities. So how can we, it's all well and good doing this nice project for Heyfield, but how to get that impact that UTS and our institute is always seeking for? How can you scale it? How can you replicate it? So we're very focused on this and how we're going to help others proceed on the same journey and hopefully not have to repeat a lot of the same steps. So these are the Watt Watchers devices. So you can buy these. Anybody can buy these devices, a few $100s, and really this was about getting them installed in the community so we could understand, okay, well, before we prescribe a microgrid, like how much energy do people use, how much solar do they generate, how much is a load which could be shifted, so how much is maybe pumps, pool pumps, or water heaters. What other devices do people, how else is their energy used in their homes and businesses and schools and farms. So we had 98, that's the number of energy audits and some expressions of interest we had. So we actually had a special platform called EcoLogic, which you could just do on your smartphone. And we got people to undertake their own energy audits. We also helped them with that. It was actually quite a useful community engagement tool. We've got 74 sites installed in total, and you see the breakdown there. We've got 20 sites on the waiting list ready to install, and in total, the aim, we expect to install 93 by the end. And as part of this package, you get the devices, you get the installation, you get the subscription to the app for the 3 years. So everybody who's part of the project is completely free, all funded by the project. This is what you get, and the project lead, Watt Watchers, provides and manages that. This is just some insights from the project dashboard. So within the project, we've got we're going to have 3 or 4 screens located in the IGA and the Community Resource Centre, just displaying some real-time information and other highlights. At the moment, this is our sort of beta dashboard. So here on the left, you see where the devices are, and it's aggregated. So you can actually see who's, can zoom in and say, oh, that person's left their, they've left their lights on, or they've got their TV standby on. It's kind of aggregated, but you can see roughly how many are in each part of the town. And here on the right, you've got a breakdown just for one day, just to give you an example. So really telling you, okay, when's the lowest? And this top one is like over the course of a day. When's the lowest? When's the lowest demand, and when's the peak? And also on that bottom, again, that's your solar generation. So against total demand as well. So it's just saying, basically between 9 and 5, you've got this excess solar here in February, so sort of late summer. So again, this is how we're trying to build a picture to see what's actually possible with the microgrid and where the opportunities are. This is the milestone 3 report. So as I said, we're about halfway through the 3-year project. And as part of this was really taking a step back and saying, okay, what have we learned? A lot of this is about how we can help other projects and other communities. And this report, we basically split into 4 main sections. So where to get started, community participation, communication strategy and tools, and technology deployment and participant recruitment. This report, if anybody wants a copy, completely happy to share it. And I'll probably share it with you and Mary as well. It will be available on the UTS and Community Resource Centre's websites soon, and we'll be putting all the milestones up there. I'm conscious about time, so I'll maybe just focus on one of the lessons learned, and happy to come back to any of the other sections. So one of the main things was around, okay, where do you start? So we spent a lot of time looking for a community, who to partner with, and we had a number of failed funding attempts. We're well aware of Yackandandah, and we've been involved with them in another project. Where could we find another Yackandandah? And Heyfield came on the radar. They've been doing sustainability initiatives for 10, 12 years. and they've been a fantastic community to work with. We didn't get the right funding on the 2 or 3 times we went for other grants, but this one was really squarely was really well suited to the aim of the project, this path to impact through replication and scalability. We had a really defined theory of change. What do we want to do through the project? And we had a vision workshop right at the start to really sort of define this for the community. And also avoiding a narrow view of what your final technology solution will be. Now, this is hard when your project's called Microgrid and the grant funding is microgrid funding. But as I was saying with the panel just before the call, it's, we're keeping an open mind. We don't want to just say, okay, it's a feasibility for microgrid. Microgrid's not feasible, end of story. We really want to work out how to hit those points which Matt talked about. People want to know how they can make energy work better for them, reduce their bills, reduce their carbon emissions, and drive social economic benefits as well to their town, and not just have it limited to Heyfield, but they'd like to see the benefits flow over to the surrounding area. I shall skip through these, but obviously I'm assuming everybody will get the slides. The last thing to say is we're actually doing a free community webinar ourselves on Monday. You're all welcome, and it's being run by the My Town Microgrid team. We delivered by Murray, who's Hogarth from the Watt Watchers team, and the webinar series is called Microgrid versus the Grid. So I'm sure it'll be of interest to the folks here as well. So that's me. So I've run a little bit over, and yeah, happy to take questions at the end.
Thank you, Scott. That was quite interesting, and it was really good to know all the progress and all the learnings so far. Now I would like to invite our last speaker, Nick Mason-Smith, analyst from Indigo Power, to talk to us about their main activities and goals.
All right, thanks for the introduction. Is that showing up?
Yes, it is.
All right. Well, thanks very much for having me. I'm pleased to be speaking to you all and speaking with Scott and Matt. I'm relatively new to Indigo Power, so I'm funded out of a regional and remote community reliability fund grant, and I'll talk a little bit about that project. But really, what I wanted to do with this talk was to talk about where we are today. I think there's a shared vision of what the future is, and I want to try and talk about, from Indigo Power's perspective, but also, from all of our perspective, some of the next steps and really how we get towards that vision. Right. So a little bit about Indigo Power. And I'll try and fly through this reasonably quickly. So we're, as Matt said, really an outgrowth of community energy groups, especially Totally Renewable Yackandandah in those community energy groups in Northeast Victoria. So we're a community-owned energy retailer. We've got 275 shareholders. We've got an office in Beechworth. I'm currently in the office in Beechworth. We're a certified social enterprise. So our commitment in our constitution is that we will give 50% of our profits to community energy groups. And our purpose is to deliver 100% renewable energy across our region in a way that supports and empowers communities. We have a retail offering. We also do projects. So mine is an example of that, and I'll just touch on some of the work we're doing in Corrion. We own and operate the Yack community battery, Yack 1, that is, which is fed by a 65 kilowatt solar array, and it's 274 kilowatt hour battery. We also have energy sharing, which is an information portal to help people understand of the Indigo Power customers in their community, how much of their usage is coming from energy generated in that community. So the vision I think that we share is of this smart, interconnected, distributed energy future, and particularly with resilience around emergency events. And that goes to what Matt was saying about islandable microgrids. And I think there's a shared interest in that vision, particularly for fringe of grid places that have energy vulnerability. And Corrion is a particular example that I'll just touch on, where we're doing some work to try and improve their energy reliability. So really the pathway that we see towards towards this kind of microgrid future is that the immediate next step is around energy nodes and doing things with community batteries. So energy nodes, what we're referring to there is critical sites that we're bolstering with local generation, storage and backup. So even if a particular town doesn't have energy, there are particular sites, critical sites, that have power where people could go and have a hot shower, go and charge their phones, cook a meal, those sorts of things. And I'll touch on those specific sites. That feeds into virtual power plants, which is partly what I'm doing, but really my project is around community batteries, and ultimately this vision is of microgrids and islandability. So the energy nodes work that we're doing in Corrion, the goal there is to create a power supply that will run for extended periods during outages. My colleague Heath is working on this, and we're partnering with, we work with Upper Murray Incorporated. There's a proposed Corrion microgrid zone, but really the first step towards that is these energy nodes. And what that looks like is solar and battery systems on about 27 buildings, and having community scale batteries at 3 of those sites, and diesel backup as well. So I wanted to talk a little bit just about where we are today, the energy system as a whole, and to try and have a bit of a reality check and say there are parts where things are being done pretty seriously. Rooftop solar is this yellow part here that we see. There's still a huge amount of coal generation. Demand fluctuates quite widely, but solar is there. It's having a very significant influence during the daytime, but there is still a very large amount of coal, and we really want to increase, renewable sources. There are challenges emerging, particularly in certain parts of the grid where there is a lot of solar, and I'll touch on some of the technical reasons for those. But in order for this vision to exist, we really need to keep increasing that generation from renewable sources at small scale, at scale as well. In terms of Indigo Power's customers, so I've prepared a graph here, which what I'm looking at, so I don't see anything going on behind the meter in the sense of if you've got a solar system and you've got, say, 5 kilowatts and you're using 3 kilowatts of that, I'm not seeing that. I only see the 2 kilowatts coming out the front. So I'm looking at just the through the meter consumption generation. And if we sum this up over each day for all of Indigo Power's customers, we can see, and this is an important caveat, if we ignore the time of use, which is an important caveat, and I'll touch on why that's an important caveat, our generation is comparable, our excess generation, so the generation being sent into the grid by our solar customers, is of the same scale or equal, approximately equal to the consumption coming back in. Now, of course, that ignores time of use, and so that's assuming for this to imply that we could actually do this, you would need storage of the scale of this scale, which is quite a lot of storage. Storage is not the only solution; it's definitely part of the solution. But of course, we can see in winter as well that our consumption is very high. Our gross generation being exported by our customers is not that high. So the challenges really for now include matching consumption and generation so that their time of use overlaps. Partly we can do that with storage, but if the storage is of these scales, it does get a lot more challenging. And we need to also increase generation. We need more solar, and we need more local generation. In terms of the roadblocks to more generation, this mismatch between time of generation and time of consumption is creating extremely low daytime demand in certain parts of the grid. And for our customers, this is what this looks like up here. So when the orange line is greater than the blue line, Indigo Power's customers are a net exporter. So they're sending energy to the market. So that's energy being exported. When the blue line is greater than the orange line, that's Indigo Power being a net importer. And we can see that there's an evening peak, a 1 a.m. peak when everyone's hot water heaters come on, and a breakfast peak and then this very low daytime demand. I should add as well, it's you can see down here as well, the Yak community battery discharging from 7 p.m. until, depending on the day, 2 in the morning or so. And when we have a cloudy day, we've got much higher daytime demand. So if we can shift some of that usage through things like heat pumps and other energy efficiency devices that into that daytime peak, that reduces the amount of storage required. It also has benefits for the grid in terms of being able to increase the hosting capacity of solar. Another factor that's a roadblock to more generation, and something I think a lot of solar owners are acutely aware of, is the low daytime energy prices. So what I've plotted here is a heat map, and I'm happy to describe it in a little more detail. I'm also conscious of the time, so I don't want to, I think I might have to skip some of my slides. But what we're looking at here is Indigo Power's customers' gross generation on the horizontal axis. And then this is what's called the Victorian Regional Reference Price. So this is the wholesale price of electricity. So when you buy electricity from the market, depending on the time at any given 5-minute interval, there is a price associated with that. And what we can see here is that when the sun is shining and we're generating lots of energy, the prices tend to be quite low, which means that, you know, that electricity, if we're exporting it, we're not getting very much for it. If we had a carbon price, perhaps we could, you know, talk about these things moving around, but under the current arrangements, this is the way things work. And this green line here is the feed-in tariff, the Victorian minimum feed-in tariff. So we're seeing that this amount of solar in the system is reducing energy prices, which is going to be an impediment to more solar. Export limiting is also relevant, and this is something particularly in areas of the grid where there is a lot of solar, and there are some rule changes coming around that, but that is absolutely a roadblock to more local generation. So in terms of the things we need right now, as I see it, we need more energy storage, both local and grid scale. We need to shift energy time of use where we can, and the kinds of things that community energy groups are doing through bulk buys on heat pumps and things like that. Electric vehicles is going to be a big part of this as well. Certainly are all going to help. We need to coordinate our distributed energy resources through virtual power plants, and the rule changes that are coming through the system are also going to be helpful. I won't go into this too much, but this is to say that local storage can increase the amount of solar allowed in the grid at particular parts where there's already a lot of solar. And as an example here is just a recent story regarding Broome, where community batteries, by charging at the times when solar generation is very high, enable there to be more solar. So they're reaching limits of how much solar the system can currently tolerate. Community batteries that charge at that time can alleviate some of those issues and create room for more solar. But there's some subtleties around, you know, the Yak community battery, for example, currently doesn't do that. It's fed by a solar array behind the meter, and that's because of the network charge structure. In terms of shifting time of use, I'm conscious that we're speaking to the Grampians Community Power Hub, which is in the Power Core region. So if you're a non-solar customer in Power Core, from July this year, there is a residential daytime saver tariff that you may be able to try, and that's certainly intended to promote people using energy at those times during the middle of the day. Voluntary efforts should also be encouraged, and you know, I'm thinking, you know, thinking back to my youth, the Target 155 and those kinds of things. I think those are things that there's room for education as well. But you know, price signals are coming as well. And ultimately, virtual power plants. This is really to say that there are certain things that power plants provide in terms of their services to the electricity system beyond power. And typically those are referred to as ancillary services. Some of these can be provided by household batteries, some of them can be provided by community batteries, and we're still working out exactly how this is going to work and which of these things we can provide. frequency control is something that gets talked about a lot because it can be done in any part of the grid. It's a whole of grid issue. Whereas, for example, voltage control is much more localized. System strength, we're not clear at this stage on whether there's a role for community batteries, but it's clear that when there is a lot of solar, there is a system strength issue, and I can talk about that if people want to talk about it more. In terms of my project, just to wrap up on that, it's a feasibility study looking at aggregated community scale battery storage, and in terms of the technical aspects, we're looking at 4 sites beyond the Yak1 community battery. We're looking at batteries with depth of charge 250 to 500 kilowatt hours, totaling 1 to 2 megawatt hours, and looking at particular regions of the northeast. So we're going to look at design and grid connection. In terms of the feasibility, we need to look at the financials and commercials. So what revenue streams can these access, as well as all these other things around, particularly network support opportunities. And this project is really just getting underway, so there's not a lot to report yet on our findings, but I'll look forward to sharing all of that with you in the future. So I think that's me, but probably, I guess, just to give another plug for Power Core customers to talk to your retailer about the daytime saver. All right, and that's all from me.
Thank you, Nick. That was a great presentation. Just now moving on to some of the questions. Just to all the participants here with us tonight, if you could enter your questions in the Q&A tab, or also raise your hand in case you would like to have a chat with our speakers tonight. I guess the first question is from Kathy. Kathy says she's from Ballarat. As you know, we have had a great deal of opposition to alternate towers going through our productive farming area. Would it be feasible to microgrid the towns along the proposed transmission line route rather than send all the power to Melbourne to be then redistributed to the users? Scott, maybe you would like to, or Matt?
Yeah, I mean, one benefit of microgrids obviously is that you reduce the need for lots of distribution, distribution pipes and poles and wires. But again, with something like, it's hard to say without looking at the network topography. I mean, microgrids typically work better at the true microgrid at the fringe of grid where there's one connection point to the main grid, but it's hard to say without actually getting into the detail and seeing what the network looks like in those areas.
And I would probably agree that the transmission lines are very different parts of the electricity supply system, and transmission takes it from large places of generation, and historically that's been coal, but more recently obviously that's around solar farms and wind farms, and that transports it to large population centres. And I guess the intention of the question was, can we avoid carting it off to large population centres and then sending it back out on the distribution system? And I think that in the future is something that's entirely possible. And one of the interesting things that all of the networks are confronting about what is it that networks look like in the future, and if many communities adopt localized approaches to electricity, and whether they're virtual power plants or microgrids and all the strengths they offer, it does mean that the amount of electricity that needs to be distributed goes down. But the broader vision that's being painted in the energy industry, and the Australian Energy Market Operator is heading in this direction, is by having really robust transmission lines, it means that we can move large volumes of electricity around the country really effectively. And so if it's shady in one spot during the day from cloud or smoke or something else, then you can draw power from wind farms or sunny spots elsewhere. And I was just reminded a couple of weeks ago by an old neighbour where I grew up, and in the 80s there was the same discussions going on about transmission associated with various changes that were going on in both the Snowy and Kiowa hydro schemes, and very contested placement of those transmission lines. But that went ahead anyway, and those transmission lines continue to work and the farms continue to be productive. But I get the challenge of what it means to local people having transmission lines placed there. But I think I've just in a long way said there is not much relationship between transmission and local microgrids, at least in the short term.
Thank you, Matt, and thank you, Scott. Moving on to the next question. So Arena has 50 million funds for microgrid projects. What exactly is involved in, and what stage do you need to get do you need to get to before you can apply?
So the fund is known as the RAMP funding, and one of the prerequisites to be eligible to apply is you need to be able to have a feasibility study completed, and presumably that feasibility study will need to demonstrate that a microgrid is feasible and probably have some sort of structure about what that looks like. So the short answer is that you need a feasibility study already having been completed.
Thanks again, Matt. With the next question from Marty Dering, is there a process that can be used to determine if a community is suitable for a microgrid? Is it level of community engagement, size of town, grid setup? That's the question.
Well, I'm sorry, I seem to be talking a bit here. So I think that the answer is that, that there's probably not so many strict limits that might apply there. And you'd have to say that both the Victorian government in our context and the federal government are really starting to invest in a whole range of microgrid trials to understand the true scope and value of a microgrid. But I mean, I've been heavily involved in my work in some microgrids in remote settings that were bushfire affected. And it's possible to imagine that both the governments, various governments, and the network providers see really strong opportunity for microgrids in places that are either vulnerable to power outage, and whether that's because of a vulnerability to emergencies, or that they're in fringe of grid locations where the power supply is always or potentially always a little bit vulnerable to outage. So you'd say that at the moment seems to be the place that really is attracting microgrid attention.
I just add to that as well. I mean, this is the point of our funded project, is to understand, okay, what is the process that communities can go through. Obviously, the steps to understanding the feasibility. There's certain steps which, you know, what is the right path? What are the right questions to ask? What parts can the community do themselves? What parts you need to bring in specialist technical expertise? And this is something that we're charting at the moment. And again, the types of toolkits, guides, decision support that we're developing as part of our project will help map out that process. So we don't have the answer yet, Marty, but watch this space, and we'll hopefully be sharing that at the end of our project.
Thank you, Matt. Thank you, Scott. Another question from Warwick. What happens to the excess power generated within the microgrid?
Well, there is no excess power in one sense. At least in a grid, the generation and consumption must match. At least that's true of the broader energy system. So if you have an enormous number of houses generating power, your voltage is potentially going to wander high. So I think that's something where community batteries potentially have an important role to play, as well as household batteries in managing voltage. But I'll let the other speakers speak to that as well.
So, yeah, I would agree. And one of the essential features of a microgrid is the capability to be able to have smart controls over individual systems so that you can get the whole collection of participating sites working cooperatively. And so a smart controller in a microgrid typically has the ability to be able to both wind up, for the want of a better term, or wind down the performance of generation, and whether that generator is solar or wind or a physical diesel generator or some other type of generator. So you do need something that can control that, and that's especially relevant where a microgrid is operating in its islanded capacity. And load banks might also become very important in that scenario. And load banks could include turning hot water systems on or other discretionary loads within the microgrid, pool pumps, air conditioning, yeah, there's charging cars, a whole range of discretionary loads that could be in a microgrid to essentially use electricity that's unneeded.
Thank you, Matt and Nick. So another question from Warwick. With the microgrid, do all homes in a defined area need to be part of the grid?
So Scott and I worked together on a program for a microgrid in Yackandandah, and the specific purpose of that microgrid funded by the government was really to understand how can microgrids be used to manage local network constraints. And in that circumstance, there was a particular type of electricity network called a swirl line, or a single wire earth return. You probably have seen them all over the place. They're essentially extension cords draped across paddocks. And that project that we worked on was 103 discrete electricity meters, and the people who chose to participate in the trial and researched by University of Technology Sydney were only 14 homes, and those 14 homes received solar, battery and smart energy controllers, and that project, working with AusNet Services, the network provider, and a company called Mondo who build the smart energy controller, were able to really very effectively manage the constraint with just those 14 homes and improve the power supply for all 103 customers. And interestingly, at the end of that trial, the network was upgraded. It was always intended to be upgraded. And so the need for the microgrid diminished after that, although the property owners still kept their solar and battery system. We've just been doing some trials on those groups of homes just lately, and we've discovered that some of the settings that were left in place with the smart energy controllers continued to mask some network discrepancies that have since been fixed, but that capability was continuing to provide some voltage support for the network.
Thank you, Matt. Question from Barry. How do grid members connect? Is there a second set of wires beside the grid wires?
I'm happy to answer that. No, the absolute intention is to use the existing and already funded network assets, and that the real point of difference is that you adopt a property by property level of control to get that microgrid to work with the existing network.
Perfect, thank you. Thanks, Matt. Question from Russell. Has an effective power islanding system been developed in rural Victoria? If so, where and how does it operate within the distributor's network? FCAS charges appear to be variable and do not provide an incentive to support these services to distributors. Is this the case now?
I can probably talk to the last one of those, that second part on FCAS charges. So so frequency control ancillary services, really that's something that people looking at batteries have, and some of the big batteries have made a lot of their revenue out of providing these services. And predicting the future on that, I think it's hard to say exactly where it's going, but it's definitely variable. I absolutely agree with that. There is an emerging market for 2-second FCAS, so even faster. So really what this is doing is, in the event that in the grid at large, either a generator comes offline or something along those lines, then a FCAS provider provides energy into the grid to prevent the frequency from wandering. And the money coming from it is changing. It is variable, but in terms of the economics of batteries at the moment, or the commerciality of batteries at the moment, it really is a bit of a case of Charles Dickens's Mr. Micawber, where income £20, outgoings £19, 19 shillings and sixpence is happiness, and income £20, outgoings £20 and sixpence is result misery. So really, when you're talking about the difference, your margin being the difference between two very, very large numbers, you don't want to start striking things off one of those columns, or the column that's helping you. So we're really not ruling that out at the moment, even though it is variable and seemingly is on a downward trajectory.
Nick, I won't offer any kind of literary references, but I'm aware of one township that is network connected, that is islandable, and that township is Malakuta. And so the network provider there is AusNet Services, and what they have as a result of quite a history of outages and supply questions is that AusNet Services installed a generator and a battery that operate in tandem, and that on many occasions that system, which is called MAGS, and that is able to island the town without anybody in the town being aware that it's occurred. There has been some technical challenges in getting it to continue to work. There's some protocols around operations of generators that haven't especially worked well with batteries, and it's associated with some of the international standards for generators, meaning that the system trips more than it should. So those problems are being isolated. More generally, there are a range of towns that are already islanded, that they've never been connected to the electricity network. And two examples of that, and I know there's others. One is in a little town called Lycola, and Lycola is on the McAllister River in Gippsland. And essentially it's a company town. Lions have a large camp there, and within the last 2 years they converted the microgrid, which was entirely powered by a generator, to be focused mainly on solar panels and batteries, and the generator continues to provide power when it's needed. So that's one already automatically islanded microgrid that's not connected to the network, and there's another just on the outskirts of the township of Heyfield called Mora, and they've always been a microgrid and never been connected to the network. And I'm sure there's many others as well.
Thank you, Matt. Another question from Russell again. Certified social enterprises are interesting business developments, and you mentioned that you had a number of shareholders. Do they receive a dividend first before profit distribution to funding priorities?
I'm just trying to understand exactly what you mean by funding priorities there, Russell, but I guess to speak to the model of Indigo Power, the commitment is that 50% of profits would go to shareholders and 50% would go to community energy groups.
Thank you, Nick.
But if you can clarify what you mean by funding priority, maybe I can speak more to that.
Russell, if you'd like to raise your hand and maybe ask and clarify your question. Otherwise, we'll move on. Question from Gil Hopkins. Our community has houses in clumps distributed across about 15 kilometers. Should we be thinking about microgrid or community battery, as many of us have solar and some aren't grid connected?
Yeah, I can try and answer that one. I mean, Jill, it's I guess one of the lessons learned from our interim report was around communities try not to fix on a single technical solution. You know, what is it you're trying to do? So are you trying to achieve you know, you're trying to share energy, are you trying to go for greater resilience or reliability? Are you trying to, you know, hit a certain amount of renewable target, or reduce energy costs for people, or reduce the dependency on backup generation? So I'd say that's maybe a good place to start and think, okay, what is it you're trying to achieve? 15 kilometers, that sounds like it's quite diffuse and spread out. But again, a lot of it depends on what does the network topography look like? Where's the, you know, where the distribution network, where's the different substations? So, but I mean, there's a lot to unpack there, Jill. So, yeah, difficult to really prescribe a solution, you know, based on that, I think.
Thanks, Scott.
Sorry, that doesn't help, Jill. So but it sounds an interesting problem. But yeah, speak to your neighbours and have a discussion, see what it is you're all trying to, what you'd like to achieve, and what's your sort of vision for your community.
Thank you, Scott. Next question. Are microgrids feasible in urban areas?
That's an interesting question. We were just finishing a project just now looking at, and the concept is urban renewable energy zones. So taking the large scale renewable energy zones and applying it to an urban context, and really looking at how you can facilitate solutions like community batteries, microgrids, you know, VPPs, other solutions in urban areas where typically there's you've got a lot of renters. There's other challenges from an urban context. I mean, one of the advantages within urban centres is there's actually, you know, the network is, you know, it's pretty built out, and actually when we're speaking to a lot of the network service providers, they're saying, well, actually we've got a lot of capacity where we can take on renewable, additional renewable capacity, so it's not a constraint issue, and they're interested in how can we maximise. So microgrids in urban areas were also investigated as part of the Victorian Government's microgrid programme as well, varying degrees of success. So yeah, so they are possible, but again, it depends. A follow-up question from Kenneth: what is resilience versus reliability? So yeah, good question. Reliability, when we refer to it, it's, you know, if you have 10 interruptions, you know, 10 power cuts a year, if you improve reliability, you'd go down to having, you know, less than 10, you'd have 5 or 1 or none. Resilience, we usually define that as either if there's a power cut coming, you know, it's the ability to restore power really quickly, or to avoid that happening in the first place. So yeah, they're quite similar, but there's a sort of subtle difference in the way we define them and find them defined in the literature.
Next question from Russell, to you, Nick, I think 50% profits to shareholders and the remainder to fund community projects. What's the rate of return for shareholders?
I don't want to say anything wrong, and so I'm really not too sure of that. Matt, you'd probably be a shareholder, so perhaps I could let you field that one, but perhaps I can contact you, Russell, afterwards and speak to some of my colleagues.
Yeah, so it's sort of it's an interesting scenario. I am a shareholder in Indigo Power, and at this stage, Indigo Power hasn't returned any profits back to either community projects or indeed to shareholders. And what will happen in any instance when there is profits to be shared, it would be a combination of discussion with the board members. And Indigo Power has also established an entity called the, oh, you might have to help me, Nick, the Indigo Power Foundation, which is aiming to achieve a DGR status and be able to both raise money through grants and issue tax invoices as well, but then also invest in community projects. So I don't think the question has yet been resolved because it hasn't needed to be, but it is a company that needs to report to its shareholders, and so decisions will be made and then shared with the shareholders in a fair way. I think you'd have to say that the spirit of the investors in Indigo Power is very much about activating a really important transition in the electricity network and seeking to make sure that we get focused on how that can happen in a way that benefits local communities, and that being the celebrated goal rather than people intending to make a lot of money out of the process. But I think, Russell, it's a really good question, and I'm sorry I don't have a great answer.
As am I.
Thanks, Matt and Nick. Scott, this one's for you from Kenneth. What is resilience versus reliability in this discussion?
Well, I think I answered that one at the end of the last question. So, you know, so for a microgrid, your reliability is, you know, it stops. So when the grid starts to fail, the microgrid stops. You know, prevents the loss of supply. Resilience is if it has failed, it helps. It restores power quickly. So they're similar, but there are subtle differences.
Thanks, Scott. Question from Russell again. So to Matt, I think the Malakuta Power Islanding example is really a supply side equation and not interrelated to the grid. So not really a power islanding system in the whole sense of the concept where distribution services and grid power used to charge batteries. So there are not really any live examples of grid-connected power islanding examples yet?
Yeah, so the Victorian government has just invested in a program called the Community Microgrids and Sustainable Energy Program. And it's a good technical point you've made there, Russell. The Community Microgrids program via the Victorian government is working with AusNet Services and Mondo and the community of Malakuta to more effectively integrate the demand side. And what that looks like is a whole series of smart energy controllers across the town, particularly focused on properties with solar generation, and also the large-scale rollout of heat pumps. And one of the things that's become very evident in Yackandandah and in fact many country towns is how much power is used by electric storage hot water. Yeah. And so because hot water heating is more discretionary load within reason, you can shift the time that you make hot water to great effect on the local electricity performance. So in Malakuta, the individual properties will be receiving smart energy controllers to really effectively manage the performance of the local solar systems. and also integrate that with hot water services so that you are using that as a physical storage of electricity. In the other two towns that dealt with sponsoring, Corryong, which Nick has referenced, and a little township of Sowmya, the program is financially supporting, and the details are yet to be established, but financially supporting the addition of batteries with smart energy controllers, with the explicit intent of making that town islandable on the strength of township level batteries, community level batteries, and residential scale batteries, as well as some at a larger key buildings that you could call them. And so that would typically be a CFA, SES, ambulance station, Victoria Police perhaps, critical buildings that you really want to have active in an emergency circumstance. And so yes, that is still underway, and that will probably be active by the end of the year, you would say.
Thanks, Matt. Just the last two questions, and maybe we can wind up, as we are really running out of time. So what are the challenges working with distributors in this space?
Yeah, I can have a first crack at that. I mean, the distributors, I mean, they're essential, really part of these projects, and we've got the AusNet services as a project partner. But with any large organisation, you know, being able to, you know, we require a lot of data. The distributors have lots of data, but like, who owns it? Where does it exist? You have to provide the right processes, and we've got our own ethics at the university. So acquiring the data can be challenging, and negotiating that. And but yeah, they're an essential part of the picture, and there's been some really supportive people in AusNet services, and you know, they were there from the very initial concept of development of the project right through to the, and believe they're right through to the end. So that's my answer.
Thanks, Scott. And questions from Russell. How do companies like Power Ledger help microgrids dispatch energy at the most profitable time? PowerCo do not deal with Power Ledger or their like. Is there any vision on taking advantage of dispatchable power at optimum market prices?
I'm not familiar with Power Ledger, unfortunately, Russell, so I'll have to let someone else field that. But in terms of community batteries taking advantage of dispatchable power at optimum market prices, as I showed before, the Yak battery currently is on a very simple timer, and even with that, it's picking up a reasonable amount of the value in the energy market. But there's certainly a lot more sophisticated things that batteries can do, and batteries are particularly fast. So they can be very dynamic.
Thanks, Nick. And I guess this is the last question for tonight from Russell. What type of commercial terms do you apply for the retail energy you provide? I guess, Nick?
Well, if you're in AusNet, compare your bill and check us out. If that's the nature of the question. We don't offer power in PowerCo currently. So, but if you're interested, then get in contact with us.
Thanks, Nick. And thank you everyone for the really great presentations tonight. And thanks for all the participants. The video of the webinar will be available on the Breeze YouTube channel after a few days. And as mentioned by our speakers, the slides would be available also for reference. Thanks everyone, and have a lovely night. Thank you.